Hi, everybody again. So I will introduce myself again. So I'm Tariq. I'm working for Jefferson Wells and I will be your moderator today for this event. So I'm seeing that some people are still coming, but we will start in a few seconds. So welcome again to this webinar regarding the transfer of analytical methods between laboratories. I will introduce you to our key speaker today, Pierre. Hi, Pierre.
Hello. Hello, everyone. Good afternoon.
Hello, Pierre. So I will briefly introduce you to Pierre, and he will speak about his career next in few minutes. So Pierre has 36 years of experience at GSK Vaccines, and he spent his last 10 years more specifically on the transfer of analytical tests between GSK vaccine sites. Welcome to this event and thank you, Pierre, for this presentation. Just few rules for this event. So you have a chat, an active chat that you can use to ask questions. We will have a Q&A session after the presentation of Pierre, and I will be handling this part, and Pierre will answer to all your questions. And also, we will send you in few days, so in the coming days, the video podcast of this live webinar through your personal mailbox. Then you will have access to the presentation whenever you want. Thank you very much. Enjoy the events and see you later.
Okay, thank you, Tariq, for the presentation and for the invitation. It's a pleasure for me to be here with you and to present our way of working at GSK for, while transferring QC tests between sites. Okay, next slide. I can transfer, yes. Then this is the agenda. I will pass through quickly, then just a few words about my backgrounds, but Tariq said also a few words on that. The first question is why and when do we need to transfer the analytical tests? Of course, I will give you also the presentation objectives, the transfer steps we have, preparation phase, execution phase, and evaluation, our QC transfer process flow, then our task, because I will list our different tasks while we are transferring, how we classify the different tests, then quantitative tests, qualitative tests, simple tests, pharmacopoeial tests, the type of design, the type and the design of the transfers we do, the statistical tools we are using, even if I will not go into too much detail in statistics, how to determine the transfer criteria. It's really an important point. The samples we use to transfer the tests, because it's also an important, and the logistic part should not be undervalued. The documentations, how we document these GMP documents, and how we organize also the training of the operators, because it's really an important point also. At the end, I will just cover the challenges, the issues, and the successful transfer, the points we have to have a successful transfer. Okay, then I will not spend too much time on that because Tariq already introduced myself. Yes, then the team, I was the first one in 2010, and now we have a team. I have a team of 8 people. Of course, we are at a peak of activities for the time being. More or less, we have every year around 20 projects in parallel, 20 projects of QC transfer, analytical transfer. Of course, this presentation is focused only on the transfer of QC test. I'm not speaking about transfer of manufacturing process, which is another team working on that in Tech Transfer Group. Why and when do we need to transfer analytical methods? And there are multiple reasons. The first one is when we want to keep the initial validation status of the tests. Then the team is transferring validated tests. We don't transfer a test which is not validated. We are there also to support transfer of a manufacturing process. Then when we are transferring a process from one factory to another one, most of the time we need to transfer also some QC tests from the QC lab of the donor site to the receiving lab, where we are transferring the process of manufacturing also. When we need to increase the production, the capacity for one molecule, one vaccine, and when we need to increase also the QC capacity to release more batches. It can be the same molecule or it can be a different molecule in different sites. Or when also there are specific requirements from local authorities. Then in few countries, QC tests should be realized in the country and not in Belgium. They're not relying on the COA coming from GSK Wavre. And these countries are, for example, Japan, Russia, India, South Korea. And in some countries, like in Russia also, if you really want to be considered as a local producer, you need to have at least part of the activities, manufacturing activities, but also QC release activities. Then you may have in Russia, for example, only labeling packaging activities, but you need to have all the QC tests released locally in the country. And this is required to have access to local tenders. At the end, the goal of the transfer is to demonstrate that the receiving lab is generating equivalent results of the donor, like the donor lab. Of course, you will see that later on in the presentation, but there is always a bias between the donor lab and the receiving lab, and a bias is acceptable as long as you control the bias between these labs. And of course, you need, even if you have a bias, you need to well determine the criteria, acceptability criteria between the two labs. The other point is that everything we do should be well documented. These are GMP documents. You need to sign, control the documents, and archive the documents. Both sides should sign the documents. Of course, at the end, you should be able to defend your document transfer criteria, the choice of the criteria, and the data you obtained to the auditors in case of audits by the authorities. Then, of course, it's illustrative, but most of the transfers we do are coming from Wavre, 80% of the transfer, and most of the transfer are from GSK to another GSK site or to a CMO or CRO, to a GV or to a licensee. In few cases, few persons, we are transferring from a GV, licensee or CRO to GSK. And in that case, of course, we just reverse donor and receiving sites. You need to know that at GSK, we have several sites worldwide, primary sites, secondary sites. And of course, with the network we have today, we have more than 13, 14 sites worldwide. There are a lot of transfers ongoing. The objectives of the presentation, then at GSK, there is only one dedicated department related to the transfer. Technology transfer means transfer of the manufacturing transfer and QC transfer, which is an advantage, clearly. And that department is responsible of transferring the production process and the QC test process. The QC test is only one step among the whole step of the transfer, and I will come back quickly after that. Of course, my presentation is just giving you an idea of how we are transferring, how we are organized, just to transfer the best way without losing time during the transfer. And we are doing that through classification of the test and through a risk-based approach. I will come back on that also later. As I said already, we are transferring, in our team, we are transferring only validated methods. We don't transfer qualified or non-validated method, but this is done in R&D of GSK, in R&D department of GSK. Okay, then today we still have a process of 8 steps And the transfer of the analytical steps is the step 5, and I will focus on that today. We are in a process of simplifying our transfer process at GSK, and we will go from an 8-step process to a 4-step process, just to simplify. But at the end, the task we have will remain the same. Now I will spend a few slides on the different tasks in our team. And we have, as you can see, we have 4 columns. We have an equipment flow columns, reagents flow columns, knowledge flow, and documentation flow. And we have more or less altogether 16 tasks we are following when we are transferring one test or several tests from one site to another one. The first task is you need to create a team. You need a team on both sides. You need to identify the QC leader, which will be the SPOC, single point of contact. And we need to have one representative per site. This is an advantage. Then I would say, focus the communication through these 2 leaders, one from the donor side, one from the receiving side. The SPOC and the leader can also be someone from another site, a third site, which is a little bit more complicated, but the principle is the same. And the team is preparing the transfer strategy and the list of tests to be transferred. They are also preparing the step 2, the task 2, which is organizing the kickoff meeting. During the kickoff meeting, which is a face-to-face, most of the time it was a face-to-face meeting in the past. Now it is done remotely because of the COVID situation. We are listing, of course, the process to be transferred, but from my team, we are listing the test to be transferred. We list the specification of the tests. We list and we present the transfer strategy for the different tests we have to transfer and the classification of the tests. Of course, this is a team meeting of discussion, and of course, it's an open discussion. Then the task number 3 is we need to organize and to collect the QC documentation, QC from the donor side, the SOP, the procedures, the validation protocol and reports. We need to give to the donor site the list of equipments to be purchased or to be used if they are already equipped in their lab. We need to collect all the reagents required to be shared for the transfer of the test and to succeed in transferring the test. Task number 4, we write a QC risk assessments. The QC risk assessment is part of the global risk assessment of the project when we are transferring manufacturing process. And this is really important to evaluate all the risk we may face during a transfer. Then normally we say because of this and this, there is risk that this and this. And then we calculate the risk index and we think to evaluate and to put in place mitigation plan to avoid this risk and to put in place. We do that 3 times. I will come back on that. We do that at the beginning of a project. We evaluate the risk assessment in the middle of the project at the time of production of the PPQ batches. And we do that at the end of the project to evaluate the remaining risk at the end of the project. It works? Yes. Okay. Then task number 5, we write what we call a test transfer plan, which is a GMP document where we list all the tests which will be transferred, the classification of the tests, quantitative, qualitative, pharmacopoeial test, limit test, simple tests. We describe the strategy we have of the transfer, and we list also all the other documents we will have to write to demonstrate the equivalence for some tests. Not for all the tests, but for some quantitative critical tests. Then you need to organize the training. The training, most of the time, it's organized at the donor sites, on sites, training is preferable, of course, when possible. And because of the COVID situation, we are doing that through videos, which is less, I would say, important, less well done. I mean, because there are some details that people cannot see through videos. The task number 7 is the receiving lab should purchase the equipments they don't have on site, and they need to qualify the equipments if these are new equipments. The best is, of course, to stick to the same model and type of equipments we have at the donor site, just to avoid problems, issues, but you cannot avoid all the issues, because in many transfers, we are living with the equipments available at receiving site. You cannot, for the task number 8, underestimate the logistic aspects of the transfers. You need to share the reagents. You need to evaluate the stocks. The stock of reagents you have, you need to, of course, to share some reagents with the receiving lab. You need to organize shipments of the samples and respect the cold chain. And the same reagent, the same standard, the same internal control should be used during the transfer. Task number 9, we are writing what we call the AMTP, Analytical Method Transfer Protocol, where we are defining test per test the criteria, the transfer criteria, what will be acceptable in the equivalence we will do, or if it's not an equivalence, what will be anyway the transfer the results we are expecting from the receiving site. And then you ask when the receiving lab has followed the training, has received the reagents, has all the equipments qualified, and they will start the trial tests. And this is really important also for the receiving site to do some feasibility tests, trial tests, before conducting the AMTP executions, because they need to solve the technical issues they may face while performing the test. And there are all the times there are some technical issues, because the SOP is not clear enough, because they were not aware of some details. Then it's much better to do trial tests and to solve technical issue in advance than to go immediately to the task number 11 through the AMTP execution. Then normally for the AMTP executions, my team is giving the green light to start the experiments described in the protocol. We will not give the green light as long as we are not sure that all technical issues have been solved. Task number 12. After the executions, we are analyzing the results statistically from both teams, and we are using to analyze statistically the results the Minitab. I will come back on that. We are also analyzing the deviation or the events. You may face some issues during the analysis, and of course you need to document that. After that, you write the reports, the transfer report, and in the report you document the deviations. Task number 14, we conduct an after-action review to evaluate what went well and what needs to be improved. And what is really key in the transfer is the communications. You really need to have a clear and good communication between sites and to build trust between people. It's really important. Next task is to organize a TCO for transfer closeout meeting, with sometimes only with QC team, sometimes with the process transfer team, to review how it happened and the remaining risk of the risk assessment. And we do that at the end of the project, most of the time after the production of the PPQ batches, the consistency batches. We write, after the TCO, we formalize the TCO by writing a test transfer report. signed by everyone also. Okay, a few words about the test classification. Then we classify the test as quantitative when we are expecting an exact value, antigen content by ELISA, aluminum content. And for quantitative tests, most of the time we do a comparison of results between us. And in some cases, for critical tests, we do an equivalence test. We have qualitative tests, positive or negative, pass or fail, and we only do in that case a confirmation testing. Of course, the receiving lab should be trained and should perform the test also and get the right results, of course. For simple tests, then we only do a training, and practice can be done also, and training can be organized also. And also, in-house test is a test which is developed by the company, not necessarily described in the pharmacopoeia. And you also have pharmacopoeial tests which are considered as validated and does not require to be transferred, but in some cases verified and validated locally according to ICH guidelines. I think I need to speed up a little bit. The critical point, an important point to take into account, is for the determination of the transfer criteria. We do that mainly for quantitative tests. Then this is, of course, based on the test complexity. And in that case, we do a comparative testing on both labs. As I said, an equivalence. I will come back on the TOAS test, which is the two one-sided tests used to demonstrate the equivalence between sites. And the transfer criteria are based on the validation results and test variability from the validation protocol or the validation reports of the donor site. It's just an example. For example, we can expect 15% of variability for an ELISA and 2 to 5% for an HPLC, for example. In some cases, we are taking into account not the percentage of variability from the protocol, but the intermediate precision observed in the reports, in the real validation report. In that case, of course, the variability is lower than the limit fixed in the protocol. I will speak a little bit about the PPK, which is the capability of the method and which is reflecting the robustness of the test and the robustness of the manufacturing process. And we will speak a little bit about the out of specification risk also. Comparison type of transfer, comparison testing, quantitative test mainly. Both labs are doing the tests with one or two operators. We prefer to use two operators, but it's not always possible. And we use most of the time one batch. One batch is enough as according to what is said in the USP, but you can use up to 3 batches, not a problem also. We avoid to use sometimes the batches to avoid to increase the workload at the QC lab in Belgium by using the internal control. If the internal control, which is a control which is used on routine basis in the lab, if the internal control is representative of the batch we are testing. And most of the time, we are sticking to n equal 12 values, 12 data, but I will come back also on that because you may also increase the number of independent sessions in case you need more power in your tests. Confirmation testing, then for qualitative tests, we do only a confirmation testing, and then the lab should demonstrate that they are able to perform the test and get the right results. For simple tests, as I said, also training and practice is sufficient. And in few cases, not a lot, but few cases, there is no transfer at all because the lab has already experience of the test or in the tests. This is just an example of design of experience with 12 sessions, first 8 sessions with 2 operators with 1 batch, and all these sessions should be independent for all the preparation of the solutions. When we are applying the equivalence test, the TOAS tests, we are practicing the sequential approach. Then we are evaluating the dose, the equivalence after 8 sessions. If we are equivalence, we stop. We don't go up to 12. If we don't have the complete equivalence, then we can pursue the test up to have n equal 12 or even more in case we think that we can reach the equivalence with more data. When we use the internal control, of course, we do comparisons between the receiving site with 12 values and the donor site with sometimes more than 50 or 100 values. This is also possible. Equivalence. Okay, just a few words about the statistical tool we are using. This is really, I would say, accepted, and this is the preference of the authorities now to use an equivalence test and not another statistical test. And of course, we need to determine the interval plus theta minus theta around 0, or plus 1 on theta and plus theta if you are transferring your data in logarithmic around 1. And you can see here the two first, I would say, results of equivalence are within the criteria, acceptance criteria. Then the equivalence will be accepted, whatever the interval or the confidence limits or the the variation of results obtained at the receiving site. If you are outside the limits, you are inconclusive. In that case, you need to evaluate why you are inconclusive. Is it because of the variability of the operators at the receiving site, or because of some other issues, technical issue you faced during the transfer? If you are completely out of the range, then the transfer is failed. In that case, you really need to investigate the root, find the root cause, and take the corrective action before restarting the transfer, and maybe restarting also the training. It's just an illustration of some results we have obtained in some previous transfer. It's an example of real transfer between two labs, between two limits in red and the results obtained, which is not too far from the value theta of 1, the average of 1. And below, we have a better view, which is using another program, which is the Minitab in that case. How to determine the transfer acceptance criteria? Clearly, based on the variability of the test, as I said before, based on the PPK of the method. If you have a PPK, which is the range divided by 3 times the standard deviation. If you have a PPK above 1.1, it's more or less a good test capability. If you have a PPK below 1, you have a lack of robustness of the test or the manufacturing process. This is also based on the risk-based analysis. Then you need to evaluate the out of specification risk because you know that there is always a bias between lab. I will show you an example. You have here the results in blue. You have the results from the donor lab. With this blue curve, the ghost curve, you have few data outside below the lower limit of specification. Then you have maybe 1 or 2% of out of specification. If the receiving lab is obtaining lower results, you will mainly increase the out of specification. In that case, you will lose more batches because it's a product risk, and you will lose batches which normally would have been accepted by the donor lab. It's a business risk. Another case may happen if the receiving lab is obtaining results above the receiving lab. In this case, you decrease the number of OS, but you may have patient risk because you will accept some batches which would have been refused and failed at the donor lab. It's an important risk also to take into consideration. This risk is more important than the business risk. These are just examples. To determine also the number of repetitions you need to take into account, you have statistical tables, and statisticians know very well how to determine the minimum number of batches you have to take into account when you do a transfer of test. Most of the time, we use n equal 12 for standard deviations equal 1 or equal 2. It depends. Then we can also go up to n equal 24 in some cases for a power of 90% confidence limits. One batch of product is enough to do a transfer. It should not be a commercial batches at GSK because we want to avoid the risk of having a fail during a transfer if a batch is on the market. It's better to use an engineering batch or another batch like a commercial batch, but in that case, it can be an expired lot, but in that case, you also need to demonstrate that the expired lot is still adequate to transfer the test. Internal control is the best solution because we know exactly the value we have to obtain. Here, it's an example of illustration how we are following an internal control through different years. And you can see that the results are very stable through the years, and you can also reduce, I would say the acceptability range of the internal control by using an internal control. The strategy may depend on the knowledge of the receiving site. Do they have experience of the test? Is it a simple test or a complicated test, qualitative or quantitative? What is the risk, as I said before, customer risk or the patient risk or business risk? Is the site doing the test doing some aseptic filling? Then the QC release should be done locally, and then the risk is higher than if the site is doing only labeling packaging, and the results are first obtained at the donor site and then repeated at the receiving site. In that case, the risk is lower. Of course, I will not spend too much time on the stability, non-stability indicating tests. It means you'd have to take into account also possible degradation of the antigen with time. In that case, you need to do the test on both sides at the same time. Documentation, then as I said, you need to document, you must comply with your current local SOP. Any justification to transfer or not transferring a test should be documented in a TTP. A paper-based knowledge transfer or a waiver transfer is acceptable, meaning that we don't transfer, but you need to justify why you are not transferring the test. And you need to build the supportive documents, TTP, MTP, MTR, and risk assessment. You need to archive them. And each site is keeping its own originals, and now most of the time we are signing electronically our documents. And all documents should be written according to GMP practices. Finalization of the QC transfer. When the report is approved, we conduct the after-action review at the end of the transfer with all parties before conducting the transfer closeout. We organize the transfer closeout all together, of course. And then another department is taking care of the life cycle of the project. Then we are stopping our support at the end of the consistency batch production produced. The TCO meeting is the end of the transfer responsibility, and we write a TTR, tech transfer report, at the end of the transfer. Operators training is really important. Then at the donor site in Belgium, we have 3 steps to qualify an operator: to observe the qualified operator doing the test, to perform the test in parallel. And the step 3 is doing the test alone, but most of the time they are doing the test when they are back in their lab. And when we are at the end of the transfer, successful transfer, we consider that this is the qualification of the operators at the receiving lab. Okay, and this is the responsibility of the receiving lab to qualify additional operators when they need to have backup, because that's why it's good to organize the training with minimum 2 operators. Challenge and issues. Of course, because of the increase of the outsourcing, there is an impact on our team. We have an increased number of transfers. There is an impact on the reagents availability. We have to share more batches, more internal control, more standards. And of course, it has an impact on the QC labs. And additional reagents validation also at the donor lab, because we have to share what we have. Pay attention to logistic issues and shipment issues, and observe the cold chain, of course. Pay attention to the selection of the batch, selection of the internal control, attention of the turnover of the operator in small site, and qualification to be maintained at the receiving site. And of course, we are facing at GSK decentralization of the test. And at the end, we need to define who will be the owner of the test's knowledge at the end. Pay attention also of the lack of robustness of some QC tests, because you may face some difficulties in the transfer if the test is not robust enough at the beginning of the transfer. Challenge and issues, of course. One of the challenges, if this is not a priority at the donor units in some departments, then it's difficult for us to get support from the donor lab. If there is a lack of trust, because the localization fears, for example, if the role and responsibilities are not clear at the beginning of the project, you face difficulties at the end. And if the validation documentation for the QC test are not complete, then in that case, you may face issues also. We may face issue with very old products and old tests because we don't have the right documentation. Of course, you may change the strategy in the middle of a project, but this is life, I would say. We may change the strategy for regulatory also to submit to different countries. You may face limited resources. If you don't have enough face-to-face meeting, it's also a challenge. And if the capability of the receiving side is underestimated, if you don't have the right people at the receiving side, you may face difficulties, and you need more time to train them. Language barrier, intercultural approaches is also important, and lack of time, of course. Successful transfer when you have the receiving side able to reproduce results according to the spec. Product quality occur, I can avoid that. It's also issues, robustness of the test, I discussed that. You need to have a clear strategy and clear scope at the beginning of the project. You need to have realistic and acceptable timelines also, because it takes time to transfer, and good and transparent communication is key between people. Best practice, well-define the scope, role and responsibility, team creation, history of the analytical test is important. Existing documentation, the documentation, of course, is important. And be prepared to well classify the tests before transferring the tests. Training is really important also. Do not estimate the time required to transfer. Do not underestimate also the logistic aspects. I think I've covered all the points, and keep always the communication channel open. The most difficult part is to be harmonized. If different labs are doing the same test, this is complicated. That's it. Thank you for your attention. I hope it helps you a lot. As I said, I'm not a statistician, that I did not spend too much time in statistics because you really need the help of statisticians to well define the criteria and to use the software.
Thank you very much, Pierre, for the presentation. Thanks for joining. So that's the moment. If you have any questions, we had several questions during your presentation, Pierre. For example, we had one question regarding the parameters. So what's the limit of parameters such flow rates, column temperature, pH, and so on when you have a validation method?
In fact, you need to apply exactly the same parameters at the receiving side as the ones you have at the donor side. Of course, we are transferring validated method. Then, of course, the parameters should be established before the transfer.
Okay.
Then you need to respect these parameters.
Perfect. Thank you. I hope that the question is replied now. So don't hesitate to ask some more question if you want. I've read another question. It was at the beginning. No, that's it. I think. Yeah, I think that's Abdallah Mohamed. You asked a question regarding uncertain rule. Could you please precise your question if you are still here?
You need to have a clear rule defined, I mean, in your transfer, and then you need to have a well-organized, I would say, way of transfer, way of working in your transfer, and you need to have defined criteria, well-defined criteria of the tests before transferring, and to determine the limits of the acceptability limits.
Thank you, Pierre. I'm reading the other questions. I think that's it. That's the moment. If you want to ask some question, don't be shy. You can also ask questions directly to us. We'll let you some minutes. Okay, questions are coming. So, Pierre, for LC methods, do you suggest to use different equipment, columns?
No, the best is to use the same columns, at least the same columns. You have no choice, I think. And the best is to avoid technical issues during the trial tests, during the transfer. The best is to keep as much as you can the same equipment. It's not always possible to keep the same model of equipments, but at least the same equipments.
Okay, thank you very much for your answer. We have another question. So any points of attention in terms of submitting the receiving lab? So in a standalone EMT?
Sorry, but can you repeat the question?
Yeah, of course. So any points of attention, so in terms of submitting the receiving lab in a standalone EMT?
EMT? Oh.
Yeah. In a standalone analytical method transfer, I guess, to regularly to the authorities. So that's the question.
Yes, of course. This is the goal of transferring the test. If we are transferring a test to another lab, it's also to submit to the regulatory, to the authorities, a file to, I would say, register the lab. But you will have to demonstrate that the results in that lab results are identical from the donor lab. Yes, it's always linked to a submission of a file for a new product or a new building or a new production site. Yes.
Thank you, Pierre. Another question from Marc-Antoine. So it is exactly the same way of working if you are transferring method to another GSK site or to a CMO? Good question.
Yes, but I would say we are transferring more QC tests to a GSK site than to a CMO. Then most of the time, we are not asking the CMO to do all the QC release tests of our product. they are doing a minimum. They are doing pharmacopoeial tests like sterility or identity. We are transferring some tests, but not all of them to CMOs.
Okay, so the way of working is quite the same then.
It's a question of, I would say, workload and cost.
Yeah. Thank you, Pierre. Another question, so from Eman, how could I be sure of the difference in equipments won't pose future issues, and how to test those changes specifically in gradient HPLC tests?
You need to do that during the trial test. Then you conduct some, I would say, trial tests to solve the technical issues before validating a transfer via the MTP process. They just need to practice and discuss communication, share the experience, and correct the technical issues you may face during a transfer with another equipment. But it's possible to transfer with some other equipment, another model or different equipments, of course.
Thank you, Pierre. Just to come back to a question that you've answered already, Pierre, but we have just a precision to have. So earlier, Elen asks for LC methods. So what do you suggest to use different equipment, columns? And then she asks now, is that the same column? That's the same column, but different batches? Or
Okay, then sometimes, not all the times, during the validation of a method, they are evaluating the variations from batch to batch of the column. And in some cases, in few cases, I would not say in some cases, but in few cases, they are not evaluating the change of the batches. Or the donor lab is estimating that there is no variations from batch to batch. But we have already experienced the reverse. We have already experienced a variation because of another batch was used at the receiving lab. And then we just evaluate and try to define or to scrutinize the problems we had. And it was due to the batch-to-batch variation from the supplier and not from the QC lab SOPs. Then you have to pay attention to that. You may face batch-to-batch variations from the supplier, yes.
Okay, thank you very much, Pierre. So another question. Thanks, Baptiste, for asking. So what do you think about co-validation to transfer a method instead of like a formal transfer?
It's a good solution. Then instead of doing a formal transfer, you can organize a co-validation. We are doing that in few cases, not enough, but it's a good solution. And if the test is not validated, then there is no transfer, but you may ask, I would say, the receiving lab to do the validation locally. This is also a third solution. Do the validation of the test locally. But co-validation is also a possibility. We did that only once or twice.
Perfect. Thank you, Pierre. I will come back to another question that you have already gave an answer. So it was regarding how could I be sure of the difference in equipments won't pose future issues, how to test those changes specifically in the gradient HPLC tests. And so Iman is asking also regarding waters and agilants, for example, and also acceptance criteria for equivalency.
In fact, you always have to pass through the trial test. You cannot say, okay, it will work or it will not work if you don't do some test. Then the first action is to pass through the different tasks and to have a training, to receive the reagents, to prepare your equipment, and to do the first trial test and share the values and the results you are obtaining with the donor lab, and check if this is acceptable to keep that equipment, if the equipment is different. If you have a waters in one lab and an agilants HPLC in the other one, it may work, it may fly, but you need to do some tests. That's it. I don't have a fixed answer. It is not possible.
Okay, but you advise like to make the tests.
Yes.
Yeah.
Yeah. They have to practice and to solve the technical issues first before doing the official transfer.
Okay. Thank you, Pierre. And thanks, Iman, for the questions. So Baptiste, regarding his question regarding co-validation, is I think that he wants a precision. So here is the question. So in what specific case would you rather use a co-validation?
Oh, in case you don't have the resource to do the transfer, in case both labs will continue to work together in the tests. It's another example. In case, what are the other possibilities? I'm just reflecting on what we did in the past for that co-validation. In case a test is currently outsourced to another lab and internalized into two different sites. Then we had a test which was conducted in Holland at SGS, I think. And then we decided to have it in Wavre and to have it also in Singapore. In that case, we decided to do the co-validation to internalize the tests to both sites, both GSK sites. But there are multiple factors. Manpower, resource available, and so on.
Perfect.
Cost also.
Thank you, Pierre. Hope, Baptiste, that you got your answer, and thanks for your question. I have another question here from Abdullah Mohamed. So, what's the difference between LOD and LOQ, and what's mean with precision and accuracy?
Okay, then clearly this is not the topic of the talk today. This is linked to the validation of the test. Then LOD has limit of detection, and most of the time the limit of detection is below the LOQ, which is the limit of quantification. Then we can say that the limit of quantification should be the last point or between the last point of the standard curve and the second point of the standard curve, while the limit of detection is below the first point of the curve. And for the accuracy and precision, I would just ask you just to rely and to refer to people who are doing the validation of the tests, because of course you need, or to rely on the ICH guidelines. This is well defined in the ICH guidelines.
Thank you, Pierre.
I don't have time to discuss that here now.
But if you want more precision, as we said, don't hesitate to send us a mail after the webinar. I think that Pierre will be glad to answer.
To try to answer the questions.
Yeah, exactly. Thank you. A question from Mohammed. So I have seen that even you might file transferring the methods when class of equipment from the same vendor are not the same. So regarding IH class and UPLC from Waters.
Yes, I don't have an answer for that. I'm not a specialist in HPLC, clearly. And I know the differences between HPLCs. You need to trial and to evaluate the capability of the equipments you have to do the same job, depending on the product you have to test. I don't have a clear answer for that one.
Okay,
just
thanks,
pass through trial test time.
Perfect.
Is key.
Another question. So do you only perform equivalence testing for method transfer? What about other parameters such as LOQ?
No. We are doing equivalence tests only for quantitative tests or critical tests when we do a comparison of results between sites. But for many other tests, we do just a confirmation. Then the receiving lab should just confirm that they're able to do the test and get the right results. For simple tests, we don't do, of course, comparative results, but we are just asking the receiving lab to respect the specifications. They should get good results in line with the specification. And we don't use a low Q a lot I would say has a point in our transfer. We can use maybe a LOQ to do spiking of samples. Then if you are measuring impurities, for example, then there are not a lot of, I would say, product of contaminants to be detected in the test. Then you cannot do a comparison for impurities because the level of impurities are too low. In that case, you may use, I would say, the LOQ value to do a spiking of the sample to have a sample which is quantitative in the test, and then do a comparison after that. But you have to evaluate that case by case. For some low value of antigen or samples or molecules in the sample, in fact, you have a much higher variability. You need to take that into account also. It's risky to do a comparison or an equivalence for very low value for contaminants molecule.
Thank you, Pierre, and thanks for the great question. I will ask you, Pierre, a last question
Okay.
because it's 6 p.m. So, how long should be a good timeline for transferring general HPLC method? Sorry.
Okay, if it's only one method, yeah, you can have a transfer of 3 months. You can have 3 months of transfer to do only one test. If you have a set of 5 to 10 tests, of course, the project we have can last up to 6 months, 9 months, 1 year, even more than 1 year in some cases. It depends on the number of tests you have to transfer and the difficulties of the tests.
Perfect. Thank you, Mohamed, for the question. Allez, last question from Eileen. Do you suggest to track analytical control parameters? So, for example, tailing factors in the transfer documentation, or just compare it between sites?
You need to collect all the data from the receiving sites, but you may face bad surprises in the receiving sites and discover a different tailing from the donor site. Then for me, it's a technical issue you have to solve. It's just a discussion, communication, additional training. That's the only way to solve that. Or modification of the equipment. In a few cases, maybe it's due to I would say, the retention time or the tubing system in your HPLC. You have to take all the parameters into account to evaluate why you have different results at the receiving site.
Thanks, Pierre, for answering. Thank you, Eileen, for your question. Would like to thank you for attending to this great webinar. Thanks a lot, Pierre, for sharing your knowledge. And as said earlier, so we will send you the video podcast of the recording. Then you will be able to have a look at the webinar whenever you want. And don't hesitate to ask us some question. I will forward it to Pierre, and he will be, I think, more than happy than to answer to the questions if he has, like as he said, the knowledge and to make it.
It will be a pleasure.
Thanks, Pierre, again for your time. Thank you very much.
Thank
very
you
much
also
to
for
all
your
of you,
attention.
and have a great evening.
Have a good evening. Bye.
Bye.